start by defining what is recursion. So recursion is very simple. It's not a very hard topic. I know many people do find recursion very hard, but it's very simple. For example, if I write recursion here on Google, you will see that Google will say, did you mean recursion? And if I click on it, it will again open me the same page. Okay, it will keep on opening the same page over and over again. So what do we generally mean by this? Function calling itself. Exactly, Amit. A function which is calling itself over and over again. That is recursion. So recursion has two cases. Okay, so basically, like someone might think right now that if a function is calling itself, it needs to stop, right? Like at some point in time, it needs to stop. Call itself until a failure condition. Exactly. Well, not a failure condition, a base condition. Like we can call it. Yeah, exactly. So in any particular recursion function, we have two things. One is the base call, and another is the recursive call. What are these two calls? How they work? We will understand them in with code. But before that, let's understand why do we need recursion? Because what is recursion? It's basically calling itself, right? So basically, it's doing the same thing over and over again. Like you have written a function. For example, this is the function, right? If I keep calling this function, this particular thing will keep on happening again and again, right? Now, what is the only difference that you might be doing? The parameter that you are sending might be different. Instead of n, you send n-1, or you send n/2, or you send something which is not n. This is the concept of recursion. Executing the same thing over and over again with some different values each time, sending a different value each time. But don't you think we already have something similar? Like if we just want to repeat things, we can simply do that using iteration, right? By iteration, I mean for loops and while loops. Like that's the whole purpose of for and while loop, right? That it will run things over and over again. Yeah. So it will basically run same things. Yes, exactly, Amit. Like, yeah, I'm getting to that point only. Like, why we need recursion? Like, because we already have iteration, right? We already have for loop, we already have while loop. And to be fairly honest, those are more user friendly, right? Like, I have not heard someone who is saying that, I get afraid by writing for loops. But I have heard a million people, even if you open LinkedIn today, you will see a lot of people are, cursing recursion, that it's the worst topic ever. I'm having, so much trouble in understanding recursion. Then if iteration can do the same thing, and iteration is much more user friendly, and iteration is more efficient. How is it more efficient? In recursion, compiler creates the recursion stack space, right? So compiler has to create separate stack to store the result. Iteration does not need that. When you write a for loop, you don't need to store something on the compiler separately. So recursion is also space inefficient. It's not that efficient in any way. Then why do we call recursion one of the most important topics in DSA? Well, the reason for this is that it's very simple. It's not that complex. And let me quickly show you an example of what I'm saying. Let me quickly small yeah. So this is a code, So how many of you know what the Tower of Hanoi problem states? Like, does anyone know what Tower of Hanoi is? Awesome. Yeah. Okay. No issues, Jeevan. Nitesh, no, not an issue if you don't know. It's basically a simple problem of recursion. Okay, like a simple problem which can be solved by recursion and iteration both. So for those of you who don't know about Tower of Hanoi, this is one more assignment for you. Definitely today, read about the problem of Tower of Hanoi. You don't have to solve it. You just read the problem statement, what it is basically. What does the Tower of Hanoi problem say? So do keep this in mind. Definitely read about Tower of Hanoi. But coming to my point, what I want to say is, in my college days, I was, very much interesting in saying, because my teachers also told me the same thing, that, recursion is much more simple. Like I think some of you, someone commented here as well. I think Amit, yeah, right. Amit commented that, recursion can provide you clean code. But I wanted to see this for myself only, okay, that how is it providing me clean code? So I try to write the Tower of Hanoi code, using iteration, using for loops and stuff like that. And it took me 42 lines and a lot of effort, like I had to go in front of a whiteboard, create all test cases, understand how everything is working. And it was a very much, it was a very much hard to device, like it wasn't that hard, but it was very hard to reduce an algorithm by using iteration. And it took me 42 lines, and this is only a Python code. If I'm doing the same thing in Java or C++, it will probably take much more than this. If I show you the same code in Recursion, you probably will be amazed, because this is only 3 lines of code. In 3 lines in Recursion, you can do the same thing. What iteration took 42 lines. This is the reason Recursion is so important. And like once you learn Recursion, once you get the hang of Recursion, you will be solving each and every question using Recursion. And I can prove this to you. Like, if you go today, like on the internet, and search for dynamic programming tutorials, dynamic programming can be, solved by two ways. Okay. One is using Recursion, and another one is using table. Like you can create a table, 2D table, and you can use for loop and like 2 for loops to put values there. I have seen most people use Recursion to solve dynamic programming. Dynamic programming is one of the most hard topics that is there in this particular syllabus, and people are using Recursion to solve it. So it is definitely something, like once you know Recursion has a pattern. Once you know those patterns, it's very simple to solve them. It's not that hard. So this is why we use Recursion. We know that it's inefficient. We know that it's, it takes more time to run, but still we use it because it's much more simple and clean. Because definitely no one wants to write 42 lines of code when they can do the same thing in 3 lines. So yeah, this was one thing that I wanted to discuss in Recursion. Next thing is, let's talk a little bit about one simple example to understand. I was talking about more time and more space. Exactly, Akansha. Exactly. Prose clean code, right? And simpler code, like 3 lines. So it's much more simple. So let's look at a simple example to understand how Recursion has a base call and a recursive call. So let's look at this problem. You have a value n is equal to 5. Okay, this user will provide you the value of n. Now, say if I say, sorry, just one second, let me drink some water. Sorry. So basically your input is n equals to 5, and the output that we want is 1, 2, 3, 4, 5. We saw this using iteration, right? We did this using iteration while showcasing the O of n solution, right? N is equal to 5. We need the output as 1, 2, 3, 4, 5. We simply run from 1 to 5 and we printed each and every value. That is correct, right? So now let's do this using recursion. So let's create a function foo. It will take a value of n, and let me first write the quick code, and then I will show you how this works. So int n is equal to, sorry, this is the trivial case. This is the base case. What does base case means? It means that you need to stop somewhere. Let me quickly get this code from here and paste it here to show you like how these two are related. So see, where does this loop stops? It stops when I basically becomes n. In recursion, you will do everything opposite. What do I mean by that? This is running from 1 to n. Here you are getting already n is equal to 5 from the user. So you will go from 5 to 1, not from 1 to 5. So when should you stop? This loop stopped when n became 5. You should stop when n becomes 0, because you will print the value till 1. But after that, as soon as it becomes 0, you will get out of that loop. So I'll simply return. I don't return anything because the return type is void. So I just write return. I don't add anything else. Otherwise, what I will do is I will first call foo n minus 1, and then I will print n. Now, what is the value? What is the reason of doing this? What is the reason of calling foo first and then print? The reason I'm doing this is, if I print above, like if I put this print here, the output that you will get is 5, 4, 3, 2, 1. But we don't want this. We want this 1, 2, 3, 4, 5, right? So let's understand how this is working. Ascending order, exactly, right? So see, this is what we are doing in this case. 1 sec. So let's track this algorithm. Let me quickly increase the size. So let me see how. So the first time foo is called, we call foo using the value 5. Now we check if 5 equals 0. It is not, right? 5 is not equal to 0. So what do? We call foo 4, like n minus 1. So next time foo is called here, the value of n is equal to actually 4 instead of 5. Previously it was 5. Now next time foo is called, it got actually called with n is equal to 4. But what happens to this print statement? So see, compiler does this. Compiler goes line by line from up, like from top to bottom. As soon as it got a foo function, it went inside that function. Once that function will, like once foo 4 gets completed, then only it will come back and print this n. Okay, so it will stall this until and unless this gets over. This is how programming works. This is how compilers work in general. So what will foo 4 do? Is 4 equals 0? It is not. It will return. Where and then what? Sorry, it's not equal to 0, so it won't return. So what it will do? It will call foo with the value of 3. Same thing will happen with foo 2 and foo 1. Each time n minus 1 will cause one value, like decrement of one value of n, and then we will be calling. Now for foo 1, as soon as after, like once it reaches this case, the recursion will stop. The recursion will start returning now. Right now I'm calling it this, right? Foo 5, foo 4, foo 3, foo 2, foo 1. Now I will start returning, because as soon as I called 1 minus 1, like foo of 1, and then 1 called 0, right? Foo of 0. Because n is 1, 1 minus 1 is 0. I called foo with the value of n equal to 0. So as soon as I called foo 0, what happened? I went into the base case, and now this time n is actually equal to 0. So what happened in that case? I returned from. So what did I return? I was at foo 0. I returned to the owner which called me. I returned to the parent which had called me. So who did call foo 0? Foo 1 had called foo 0, right? So instead of this arrow, now I have started returning to foo 1. Now foo 1 had called foo 0 at this position, right? This was the place where I had called foo 0, right? So now I can finally print the value. So here I will write the output. This time, what is the value of n? The value of n is 1, right? So I will print 1. Then what will happen? This function got over. Foo 1 got over. As soon as foo 1 got over, it returned back to foo 2. And foo 2 had called foo 1 here at this location. So then I print the value 2, because right now n is equal to 2. Similarly, I will keep doing this for all of those values until I go to till 5. I know making this, this is something which is, this might be fairly new to some people, and understanding this can be a little trickier. And for this reason, I would suggest that, go through this code once more yourself in the language that you write, run it on the editor, and, you're printing it. So you can see the values, how they are printing one after the another. Once you write this code, I have 2 assignments